2, 1.
Okay, welcome everyone to our second session of the Biocontrol webinar series. It's a collaborative effort between Grow Asia, the ASEAN Action Plan and Fall Armyworm, and CABI. So we are delighted to have you join us. Today we have a very packed agenda, so we're going to move through quite fast. I'm going to share the agenda very soon. I'm just going to get this worked out, just so that everyone knows how to interact in today's session. If you have any technical issues, please just try logging off and on, or you can send a message in the chat to Grow Asia. If you could also rename yourself if your name isn't right, and also put your organization in brackets, you can do that by going to the tab More, and you'll see a rename button, so you can do that there. Today, if you want to interact, which we really strongly encourage you to do so, ask lots of questions. We've got some great speakers. Please use the Q&A box there to ask all your questions. If you just want to make a comment, say a good presentation, congratulate somebody, or share something of interest to you that you would like to share with us, you can use the chat for that. Okay, and if you really would like to say something or ask a question verbally, you can also raise your hand, and if we have time, we'll give you the chance to do so. Right, moving on, we've got a very full agenda, exciting speakers. I've seen all the presentations myself, of course, and I'm actually very excited as well just to see what your questions will be, because I know there has been a lot of effort gone into this session. So just before we start, we've got already 100 people have joined us, so that's pretty good for the very first couple of minutes, and we expect quite a few more also to turn up. We had over 300 people register for this event. So we're just going to find out who's online at the moment. So Pranav, if you could launch the poll. And if you could choose the choice below which best describes where you work, what organization you work for or come from, that would be great. The host and myself and the panelists, I'm afraid, cannot vote, so don't get too excited if you're on the panel there. Have you launched it? Yep, great. And we'll give everyone another 5 seconds, 10 seconds. Okay, and we'll see those results. Oh, okay, that's great. We've got quite a lot of people from the research sector and the other, and a good mix of private sector and government. Okay, well, thank you for joining us. And I think that will lead on to our next slide. And I'd like to introduce Graham Dixie, Executive Director of Grow Asia. Graham?
Okay, well, you know, I have the pleasant task of welcoming you. And this is the third in the series of webinars. The second on biocontrol, and then the one that we had last week was on digital and technologies. And there's an extraordinary sense of building a body of knowledge and of building a community of practice that will enable us to share information, to have a much better grasp of what is going on in the sector, the new ideas and so on. And what is important about it is twofold. I mean, one is the scale of the problem. You know, we have done rough calculations that if we get the same level of crop diminution that we've seen in Africa, this could be over $100 million of lost income. And the second piece is that something that the Assistant Secretary General of the ASEAN said to us when we were explaining to him what we were doing here. He paused for a moment and he said, actually, if you can make this platform work, that we can get the public sector, the private sector, the academics, the scientists to exchange information, to react quicker and better and more cost effectively for Fall Armyworm, this would be a platform that would not only give a raison d'etre for the ASEAN Secretariat or part of it, but it will enable us to have a platform which can respond to new pests and diseases. And the one that he pointed out was, you know, what happens if the desert locust arrives here? So this is an enormous program that has been launched here by Alison, and I'm very excited to see what we learned today. Over.
Great, thank you, Graham. And just a quick shout out, as normal, to all our member states, and particularly those who have come from the working group on crops and also the expert working group on phytosanitary measures, who are also part of our task force, along with our chair, Vietnam. And I would now like to just introduce Dr. Roger Day. Just going to say a few comments from CABI, because we are doing this in collaboration with CABI, and we're very grateful for their help on this. Roger?
Thanks, Alison, and thanks, Graham, too. Hello to everyone. We are very pleased as CABI to be co-hosting this series of webinars with ASEAN and Croatia. I'm Roger Day. I lead a program on invasive species in CABI, and so we've been doing a lot of work on fall armyworm in Africa and elsewhere. And I think that's one of the points we'd like to emphasize, that we need to share experiences and learn from each other, not just within a region, but cross regions. Graham made a very important point that fall armyworm is a very bad problem, but it's certainly not the last problem we're going to have. So as we're tackling fall armyworm, let's also think about how this will build our ability to respond to the next one when it comes. And we need to be thinking about how to do that in a sustainable way, economically, socially, and of course environmentally. And that's why we're very keen on biological approaches to solving the problem, which is what we're thinking about today. Thank you, Alison.
Great, thank you, Roger, and we really appreciate working with CABI as well, so it's great to have you on board. So that actually moves me to our first speaker today, and we're off at a pace today because we do have a lot of speakers and we've got lots to share with you. It's very exciting. So I would like to introduce you to Dr. Roma Gwynn. She's an independent consultant with Biorationale, and she is a biopesticide specialist working within this area for over 35 years, and she is definitely taken a leadership role in the development and registration of many new biopesticide technologies. So she's going to talk to us today. She's going to give us an introduction at the start, and at the end she's going to come back and we're going to talk about next steps and a bit of brainstorming. Roma.
Thank you for that very nice introduction, Alison. Good morning, good afternoon and good evening, depending where you are. What I wanted to do today was just to go through a little bit about what these technologies are, because we hear a lot of different words used for them, and we hear a lot of different expressions, and it sometimes is confusing that as scientists and as commercial people, we just use the words rather casually. So I thought I'd try and help us understand a little bit about what these words are. So next slide.
Sorry.
Okay. Yeah, so you'll start to hear a term that's been used more widely, which is bioprotectants. It's the idea with this term is it's to sort of encompass everything that we're talking about. They're also sometimes called biological technologies, biocontrol solutions. And then within that, I think there's 4 categories of substances. So we have the macroorganisms. These are also called biocontrol, natural enemies, or beneficials. Then we have microorganisms, natural substances, and semiochemicals. And these tend to be called either biopesticides, biorationals, biologics, or again biocontrol, just to make it deeply confusing for us all. So what are we talking about when we talk about macroorganisms? Next. So really macroorganisms, so you have predators, parasitoids, and parasites. Predators eat other things, parasitoids very nicely lay their eggs in insects, and then parasites tend to burrow in and kill the insect. And within this project, there's consideration of each of these groups and saying, are there any organisms out there that can be usefully used to manage the fall armyworm? Next, please. Then the other group is microbial bioinsecticides. So these can be bacteria, fungi, and viruses. And for each of these, there's lots of different types of bacteria, fungi, and viruses. And what we have to think carefully about is that it's the strain that's important. So you always have to pay attention to what strain you're using, because each strain is not equal, and strains will have a different adaptation for different organisms. Next slide. So how these microbial biopesticides work is if you're a bacteria or a virus, you generally have to be ingested into the insect. So the insect, it's on the leaf and the insect has to eat it. With the Bovaria, Metarhizium, which are the fungi, then what happens with those, and sometimes with the bacteria, they can go directly through the cuticle of the insect. And why is this important? Well, this is important because in terms of thinking about where you're placing the products that you're applying relative to the insect, you need to know this and to think about it to get the best out of the products that you'll be working with. Next slide. So then the other substances are natural substances, or botanicals and plant extracts are the most common. And what's represented on this slide is the plants which have been used to derive biopesticides. And so the garlic, that's been developed for use as a nematicide. Thyme is an insecticide fungicide. The Cepabogon is limonene. Clove oil, they're insecticides. Orange oil, insecticide and fungicide. And of course, everybody probably knows what the neem is, an insecticide. Thank you. Next one. And then the third group that I'm talking about is semiochemicals. And really what these are substances that are emitted by one organism to affect the behavior of another organism, usually of the same species. Most of the ones that have come and developed commercially are known as the straight chain lepidopteran pheromones, a lovely short word to use. And these are mostly developed or widely used as mating disruption. And there's a talk later on in today's session that's going to be talking more about these and giving a lot more detail. So I'll move on now. So we have all of these technologies, but how do we use them? And there's sometimes a confusion about the name of the technology and combining it with the use. But so I drew up this table just to give some clarity around it. So we have the way in which you could use biocontrol or biopesticides. It's the introduction. This is classical biocontrol. So this is where maybe a plant has been taken from one country to another and you realize it's getting out of control. So how do you manage that? So then you have an introduction. You have a single release. The introduction of that biocontrol agent will then spread on its own. And this is usually with macroorganisms, but sometimes with microorganisms as well. Then the other strategy is conservation. And in this, you say, well, I actually have in the environment around me, I have natural enemies, I have microorganisms. So can I take actions in how I farm and how I look after them to just to preserve what I have? And also to encourage it. So an example is planting wild flower strips around farms, around fields. And these can then act as a sort of reservoir for these natural enemies, so that they're available in the field when the crop gets to the point that it's full of the pest. Then we have augmentation. Oh, sorry. Then we have augmentation. And augmentation is, well, we know there's natural enemies there. We know that there's some action already going on, but it's not coming in at the right time. So augmentation is where you have a deliberate release or deliberate spread at the right time, just to coincide when the pest is there and you're trying to sort of just strengthen what nature is doing already. And then we have inundative release, and that's probably the most common. That's what everybody knows. So inundative release is you release a lot of organisms. Next slide. Next. Yeah. This is a really simple strategy. It's what we know for pesticides. You've got a pest insect, you've got your product, you throw one against the other, and hopefully they all die. And it's the same for the biopesticides as it is for the pesticides. But you are dealing with living organisms. So how you handle them, how you deal with them needs to be a lot more thoughtful. And it needs to consider how you get the timing of the biocontrol agent and the timing of the pest. Next slide. So that strategy is really about integrated pest management. And what I've modelled on this slide is, we often hear that biopesticides don't work very well, they're not very good. That's not entirely true, they're just different. They work in a different way, and it's about understanding that difference and then how to use them. So what I've modelled here in the darker line is you have a product that only gives you 30% control, and then between applications you've got resurgence of the pest, and you can see if you have a 30% effect 3 times, you're starting to get below your damage threshold. Now the ideal is the light green line, is you never let your populations build up. So then what we're trying to do then is saying, well, okay, how costly is it to have this approach? How can we afford to do this? How can we do we put the same product in every time? Do we rotate the products? But what's important with the products is we know what percentage of the population they will control. And so I know I work with a lot of farmers, and they say, well, even if it's 50%, that's fine, as long as I know it's 50%, because I can manage that then. Next slide. And we can see that this kind of approach of multiple applications is something that was talked about in the previous webinar, and it's something that work that IRI are doing, where they've got a Bavaria bassiana, and they've looked at applying it 3 times. What's interesting about this work is we tend to think of when a pesticide is we're looking for dead insects, like how many dead insects, but when you're working with biopesticide, they have multiple attributes. And they do more than just kill the pest. So you can see on this slide that you can see an uplift in yield, and some of that uplift in yield from the Bavaria bassiana may not just be because you've killed the insect, but maybe because you're having some additional beneficial effects on the plants as a result of using these biocontrols. Next slide. What's clear about all of these technologies is there's regulatory approval, and you have to follow a regulatory process. So all biocontrols come from nature, so you need to pay attention to the access and benefit sharing, import and export rules for bringing them in, and then the registration. And within that, you have different registration mechanisms. Most of the biopesticides are regulated the same way as conventional chemicals. Macroorganisms, it depends on the country as to how they're regulated. Next slide. So that's a very brief summary through of all the different types of technologies. Hopefully you've got a slightly better understanding, but remembering always that these biological technologies can have multiple modes of action. Next slide. And what's key about these products is not just what they are, it's how they're used and how we use them wisely to interact with the right life stage of the insect and how we use them in an IPM program. Next slide. Thank you.
Sorry, everyone, it took me a little while to unmute myself. Hopefully you can hear me now. I can see Roma smiling, so that's good. Thank you so much for that presentation. Very succinct, and it gives us a very good introduction to start this session. We're going to have a few questions now, and what I'm going to urge people to do, because we need to keep moving as well, is that Roma is staying with us right to the end, and then we're having a discussion around next steps. If you can use the Q&A to ask questions, any questions that you have on biopesticides, Roma is here. She's an expert, and I encourage you to ask questions, and she will actually answer them in writing while she is with us. So I have 2 questions, Roma, at the moment. Is there a commercial product available that could help in conserving the natural enemies of fall armyworm?
Well, if you're conserving the natural enemies, this is more about how you manage your crop in your field. And you're looking for what's naturally occurring there, but what you need to think about is that anything that I'm using that's actually causing harm to those natural enemies. So it's the other way around. And so this is thinking about this in terms of the ecology of the agroecology of the field that you're working in, to take practices which don't cause harm to the natural enemies that are around naturally.
Excellent, thank you. Another question here we've got, how good is the perception of farmers regarding the use of biopesticides? And is this perception different in developed and developing countries? That's a great question. What's your experience with that, Roma?
I think farmers, there's a slightly universal truth for all farmers. All farmers tend to be a little bit skeptical unless they can see a nice dead insect. So I don't see big differences. I see sometimes when I'm working in places like Kenya, I can actually see that a lot of the farmers have a really good understanding of the ecology they're working with. And when you explain what the technology is, they have a really good understanding of using them. And that's the same in the US and in Europe as well. So I think all these technologies, we need to explain what they are. We need to explain that they're different. We need to understand well the modes of action, and we need to understand what they can do well, but what they can't do as well. And if you understand this and communicate this well to the farmers, then you're able to work out crop protection plans which uses them wisely.
Excellent, great answer. Here's a question I have. Have you noticed any endophytic action of Bavaria bassiana in corn crops?
Yeah, so this is sort of, you were used to thinking of Bavaria bassiana as an insect pathogen, and there's been quite a lot of research which has shown that they can also go inside the plants. But what I know from that is that the level of control that you get with them as an endophyte is a relatively small contribution to their use as a crop protection agent. So there may be something that they can do, but it's unlikely to be the most effective and main mode of action of them being an endophyte. And just to note, with them being an endophyte, you know, plants have got endophytes all the time. So in terms of sort of human safety, that's not an issue. It's more, they tend not to be so efficacious as an endophyte. They don't control enough of the pest.
Great, thank you. I've got a question here. Is there any studies being carried out with EPN to manage fall armyworm?
Good question. I don't know, because I had a look at that and thought, well, there must be entomopathogenic pathogenic nematodes somewhere. And I couldn't find anything, but that doesn't mean it's not being done.
Could I just chip in? There are 1 or 2 studies, and I can give an answer to that. We're
Great,
doing
Roger.
some in Africa, and there's also some elsewhere.
Yeah, I think that what we need to think about for EPNs then is they work in the soil, or they're best working in the soil, so that they're probably only going to be the best used against the life stages that are in the soil.
Yes, I think they're probably lower priority than many other microbials.
Okay, great. Thank you, Roger. And one more question here before we move on to our next speaker. What is the best time of the day to apply a biopesticide like fungal pathogen? I understand its efficacy is affected by temperature.
Yeah, so let me answer the second part, affected by temperature. So again, it depends on the strain, and it depends what temperatures you're working at. What's probably more critical than temperature is desiccation and UV. So often you'll see a recommendation on labels, and again, it's look at the labels, see what the labels say. A recommendation on the label to maybe apply in the evening, and this is when there'll be less UV and higher humidity to give your product the best chance of germinating and infecting insects. But temperature, you should have got the right strain for the country that you're working with, and most biopesticides have a reasonably wide temperature range, but they don't really like drying out, and they don't really, you know, UV can affect some, not others.
Great, thank you very much. And what I'm going to urge everyone is keep the questions coming through. There's lots actually there for you, Roma and Roger. Okay. So they will do their best to actually answer those questions in writing, and we may have some time at the end, we'll see, but they will be busy. So keep them coming through. And I'd like to now introduce our next speaker. I'd like to welcome Professor Jie Zhang. He is a professor and Deputy Director General at the Department of Biotechnology and Plant Protection at the Institute of Plant Protection in CAS. He's an expert in research and application of biopesticides, and we're delighted he could join us today. Dr. Zhang, can you unmute yourself, please?
Oops. Okay.
Yes, and just tell me when you want to move to the next slide. I'll move it to the outline for you.
Okay, I'm very glad here to introduce the research work from China. The 3 parts of my speech. Yeah, go ahead. Yeah. In the last year's the first invasion from South Asia to China, the whole year's 26 provinces covering more than 1 million hectares crops occurring this insect. Yeah, next slide. In these years, only the 6 months passed, but the area of the damage is more than last year's, and this 27th province occurring this insect, and the areas a little bit much more than last year. Yeah. Okay. Progress of technology, including the 5 the points. Next one. Yeah. Firstly, it's the grasper the rooms accurately predict the migration's route. So the monitoring and the early warning technology platform of Fall armyworms was constructed. in the country, including the radar and the lamp trip. Next slide. Developed the technology of trapping and reporting the adults by the adults trapping lamp. So this is some of the result. Please, next one. Developed the technology of sexual lure and focused adults. Special, they use the pheromone to attract the male adults. According to this, to calculate the female adults. Okay, please. Establish the forecast system for the population of the Fall Armyworm. So the under leadership by the Ministry of Agriculture. So these systems work well in the whole country, covered more than 20 provinces, the instruction and the government. Please, next one. The next slide, please. Yes. Clarify the seasonal migration and no. This one is from the Ministry of Agriculture, give the guide to use the chemical and chemical pesticide and biopesticide to control this one. So this lists only the chemical. Please, next one. Yeah, to determine the genomic type of Fall Armyworm found in China. So more than 100 individuals were sequenced. So we found that most of them from the USA, from the Florida, east of the USA. So the many of them are maize type. Although they in China sometimes they eat rice, wheat, sugar cane, and the cabbage especially. The next one, please. Next slide, please. Yeah, the management back.
Yep.
Yeah. Investigate and develop a variety of prevention and control the technique, including the 5 parts. So I introduced the biopesticides. Okay, please. Next one. Yeah.
Oh,
food attractor. Yeah, food attractant is very useful to kill them adult. Yeah, special for them female adult. It means when the adults was killed, just like the larvae in the one Chinese moon. Yeah, 600 square meter. Yeah, please, next one. Yeah. Yeah. This is a high efficacy pheromone. This is products from our institute. The one lab is very high. This is a commercial. This line, the baseline is a commercial line. The red one, the green one is from our institute. It seemed very nice. Okay, please. Next one. Yeah. The third part, I will introduce the biopesticide. Firstly, in our labs, we focus on the Bt. So this is a report. Yeah, okay. The target is a cron for the Fall Armyworms. Yeah, 2 products apply for the registration to the MOA. Yeah, so last year we finished all the experiment in the 8 provinces. Yeah, next one, please. Yeah. This is a different reports, without reports. Yeah, okay, please. Yeah, this is in the Yunnan province near the Myanmar, the border areas. Very serious. You can look here before the control. This after the control. So the new leaf is good. So the efficacy more than 80% seems good. Yeah, next one, please. Yeah, we conclude the different,
Sorry,
back.
That one.
Yeah, back. Yeah, we conclude in the different stage of the seedling. Yeah, before the hatching, the Bt should be used. Yeah, in the ear area, so the dosage should be more than the small seedling. Yeah, so and in these areas, a lot of the insects mix together in the different instars. So some chemical should be considered. Yeah, please, next one. Next slide, please. Yeah, in this year's in Anhui province, middle of China, they had a field trial to control with a different, including Bt and others, biopesticide. Yeah, next, please. Yeah, this in the field. Yeah, this is a fungi. Is from the Bt. Yeah, next one, please. Yeah, this the table shows that this is a different Bt products to control the neonate in the first instar. The efficacy is more than the 80%. So this is Bt with the NPV, the virus, and this is the Bt with fungi. It is fungi. So the singles is not so good. Combined together should nice the result. This others is a chemical, different chemical, the list here. So the similar activity, some the activity just like this, components is very high, the chemical. Some of the combination from the Bt and the others shows nice result. Please, next one. Yeah, because in the south part of China, in the annual breeding areas, Fall Armyworm is very serious to damage to the crops. So normally it's a mix together in the future from the neonate to the fourth until to fifth instar. So we choose this one to select different chemical with Bt. This is a single result, bioassay result, LC different chemicals and Bt. And next one, please. Yeah, after we test the different the ratio. This is the chemical is 1, the Bt is 100. The different ratio, the 100, the 1 to 1,000. So the co-toxicity is consistently is more than 120 is a synergen. So these two, the chemical with the Bt seems very nice, the synergen, and the others is not good. Yeah. Please, next one. Yeah. Next slide. Yeah, in the field, just last slide in the lab result is in the field, we control the 3 instar level here. And normally it's used 1 gram in the 1 Chinese move, and this another one is the 3 gram. So in the combination, we decrease the chemical and decrease the half the Bt. Here is a 100, only the 150. So the different combination show that almost the same results. This means for the big insect, the larvae, we can decrease the chemicals use. Only use the Bt, the result less than the 80%, but mixed with minimum the chemicals, pesticide should very nice results. So it means that the damage can decrease a lot. Yeah, next one, please. So we try to do a new formulation, granule. So in China, until now, nobody to create this formulation. So we use the aerials vehicle to spray this one. This is the local, from the local company of Henan province. Yeah, next one, please. Yeah, this is a very special particle. For the 1 grams, around 8,000 particles. So the size around ½ millimeter. Yeah. So use this one. This can kill, each time can carry 5 kilogram. Okay, next one. Yeah, next one, please. Next slide, please. Yeah.
Should be.
Yeah, after the spray, it's a tiny, the red point is particularly. So if in the middle night and the early morning, there's some water here, accumulate here, so they can dissolve very fast. So in the small part, the concentration of the Bt or the chemicals, pesticide, concentration is very high. So the Fall Armyworm stay here. If they eat some leaves, they will die soon. Yeah, no matter Bt or chemical pesticide. Yeah, for the one squares, for the one Chinese moves around the 600 square meters, only several minutes can spray it over. Yeah, next please. It's the first time that we do the BioAC in the field. It's a line. This is the use the spray, the chemical. It is the Bt granule. It's the different combined chemicals. Yeah. So the similar here is more than the 70 efficacy to control the insect. It's much better than the traditional spray the method. The next one, please. Yeah, for this is repeat the field trial. So here is different the concentration of the chemical. These two chemical is very high activity to the Fall Armyworm. Yeah, mixed together with the back please. Yeah, but for the Bt, the pure Bt products, around more than the 80%. So this result is quite better than the traditional spray method to use in the corn. So there's a new the formulation shows a very nice the result and can save the labors. Yeah, and the speed is very fast. Next one, please. Yeah. So conclude there's in a different stage of the insect. So we recommend 150 grams, 15 liters waters. Yeah, in the one Chinese move, sprayed the corn, the leaf. Yeah, if it's for the neonate. Yeah, before the hatching of the egg. Yeah, if some the big larvae, more than the 3 instars, we recommend more than the 300 gram bucket. Yeah, in this year, in the other stage of the corn, we recommend the Bt with chemical.
Dr. Zhang, I'm just going to have to interrupt and ask you if you can just summarize in the next 1 minute your presentation.
Okay, I'll finish. Yeah. Okay, here's the fungi. Next, please. Yeah, the with Bt show the synergy. Okay, next one. Yeah, this is summary. So the Bt and others, fungi and the virus show the nice results in China. Yeah, efficacy is more than the 77 totally. Yeah. So the Bt with the fungi has a synergy. Yeah, next slide, please. And for the special the big insects, we recommend the Bt with a chemical and others. So the new technology, including the manuals, aerials, the vehicle, and others, agriculture machine should be integrated together. Okay.
Excellent. Thank you so much. I think that comes to the end of your presentation. And we've got lots of questions. No, thank you. It's a very detailed presentation. There's a lot of good information in there. So I know there's lots of questions and we don't have too much time. So we'll ask a few questions now. And if you could answer some questions in writing, Dr. Zhang, that would be very appreciated. I have, let me just have a look here. Here's a question. Usually the biopesticide cannot be used with other chemicals, and usually farmers mix the application of fungicide and insecticides in the same tank mix. Will the fungicide affect the effectiveness of the biopesticides?
Fungicides with
such as entomophagus fungi. So do you find that? I mean, you're actually mixing different sort of combinations. Does the mixed application of a fungicide and insecticide, mixing that in the same tank, would that make a difference to the effectiveness?
For the Bt, the products, the cost is okay, similar with the chemical. But in China now, fungal products, the cost a little bit high. So I think with the Bt or with the chemical, it's need the new method to decrease the cost of this fungal pesticide.
Okay. Here's another question from Jie Zhang. Dr. Zhang, there are some existing Bt products in the market. It is less effective compared to your strain that you've mentioned. Is the strain you're using less effective or more effective than the existing products in the market?
In the market?
Yeah.
Yeah. Before that, before the Fall Armyworm invention invented to China, in the market we have no these products evolved. Yeah. So last year we began to register these products. So the end of this year, I'm sure we will get the permission and the certificate to use these products. Yeah. Before that, these products only used for the cabbage, for the diamond back mouse and stripped flea beetle and others leaf beetles control.
Excellent. Okay, here's a quick question here as well. What is the cost of applying granules by drone on a per hectare basis? Do you know that answer?
The cost of the granule
by drone on a per hectare basis.
For this new now we are trying to calculate the cost for this new formulation. For the Red Bull powders, it's the similar. The price is similar with the chemical, but okay. For the granules, maybe a little bit high. I don't think it's not a problem because the speed of the Bt products to kill the neonate is good. The speed is good, and I think the cost of Bt, although it's a new formulation, I don't think it's a problem. Actually, we worry about the fungi and MPV virus. The price, the cost, it's difficult to decrease.
Interesting.
From the company, yeah.
Interesting, thank you. Here's quite a specific question. Why is there a drop in control percentage when you combine Bt products such as KN11 with NPV or metarhizium as compared to solo application?
You mean the Bt with the NPV?
Yes.
Yeah, so just like NPV and the fungi, they can prolong times in the field to make disease to the insect. Bt is so fast, only 3 days. So the long times control the population of the insect. The NPV and the fungi is available, but for the Bt, only the protein is a crystal protein, so the times in the field is limited. So we mix together. One is fast, another one is longer to control insect.
Excellent. Okay, thank you. Thank you so much for your presentation. Extremely detailed, lots of information. There are lots of questions there. If you could go in, Dr. Zhang, and have a look at some of the questions and provide a few quick answers, we would really appreciate that just through the Q&A box. You'll be able to see them all there as a panelist. So thank you so much for joining us.
Thank you.
Thank you very much.
For thank you.
Thank you very much.
Thank you very much.
I'd like to now move on to our third speaker today. We have Pathi Srigiriraju, Director for Field Development for Asia Pacific Region, Provivi. And Provivi Provivi is an emerging company using pheromones to protect crops from major damaging insects. Welcome, Pathi. If you could just unmute yourself, and you're welcome to put your video on. Dr. Zhang, you can turn your video off now if you would like. Thank you very much.
Can you hear me okay?
We can indeed. Welcome.
All right. Yeah. Thank you very much, and good afternoon, everyone. So first of all, I would like to thank our organizers for providing an opportunity to talk about this innovative technology to manage very serious and destructive insect pests in broadacre crops like corn. Let me also take this opportunity to introduce our company that I work for, Provivi. The name actually sounds like pro to life. So we don't kill anything. So it's an emerging company. We use pheromones to protect crops from major damaging insects, primarily using mating disruption. Next slide, please. So we all know about pheromones. Pheromones are not new to us. Over the past, evolution has led to creation of very species-specific communication in the form of pheromones. Out of pheromones, there are many types of pheromones. Sex pheromones are the most prominent and most potent ones known to us, where the female emits nanogram quantities of pheromones per hour, and the males have developed very sensitive antennae to detect them to finding their potential mates. It's very simple. In nature, very long distance olfactory senses like smelling senses, search behavior emerges from a sequence of chained reactions. Odor, which is like smell, encounters and triggers the male moths to fly upwind, try to find the female where the source is coming from. So the female, as you see in the picture down there, it's emitting nanogram quantities of pheromone, and the moth gets closer and the male gets closer to the target. It becomes very attracted to the visual objects and executes a sequence of behaviors, including deceleration, leg extension, and landing. So the consistent exposure to the pheromone at close distances is also responsible for initiating a series of landing and mating behaviors that we see in nature. Next slide, please. So over many decades, as I just informed, artificially synthesized pheromones, which are naturally available in nature, are used for several reasons in agriculture. The first one being for monitoring purposes, the presence or absence of an insect pest in the region. So this method was successfully used to detect many invasive pest species, just like Fall Armyworm in the region. The next one is a mass trapping. So you put these pheromone in lures or attractants and then put them in the trap. And this method is used to kill insects with a trap and needs frequent changes of lures during the season. And this method is often ineffective due to inefficiency of traps and typical evading behaviors of the moths at close range. So the moths keep flying into these pheromone lures in the traps, and they come to the close distance, and then they say, oh, this is not a female, let me run away now. Similarly, attract and kill, pheromones, which are like plant extracts, which are like feeding stimulants, and then it can be mixed with the pheromones and then spray on the plants and come back with a harsh insecticide to kill the moths. Not a very sustainable way to manage pests. So the most effective way of using sex pheromones is to use them in a sexual confusion, and often we refer to as mating disruption. So this can be used by either making a spray application, like normal applications what we do in the crop, or by the way of slow release dispenser technologies. And this has been used for many years in high value crops like orchards and other places in developed countries. Next slide, please. So what is mating disruption? Okay, so just close your eyes and you're trying to find your friend in a very dark room. Okay, the only signal is a whisper. So you're whispering to your friend his or her name. So your friend can easily hear you because it's a dark room, but they can hear your voice. Now imagine the same situation, but add really loud music to the room. So the principle behind the mating disruption is the same. The loud music that I'm talking about is nothing but the pheromone cloud that we create to saturate the environment with pheromones similar to those released by the female insects. The female's weaker pheromone signal, like in nanogram quantities, should not be detected in the cloud to generate a successful mating disruption. So we all know what happens if there is no mating, right? Wait a minute, we're talking about insects here, okay? Some insects can reproduce without mating, but unfortunately, there are a large number of destructive insect pests that they need to mate to produce offsprings. So less mating means less viable eggs. Less viable eggs means lesser number of larvae, lesser damage, lesser insecticide applications, more natural enemies, cleaner environment, low residues on crops, more money to the farmers, high sustainability. So the list goes on. So there are lots of benefits from using mating disruption if it is successfully done. Next slide, please. So remember from the last few slides, females release insect pheromones or sex pheromones in nanogram quantities per day for calling for males. So in order to saturate the whole area, we really need high concentration of pheromone in the area to really mask the real calling females. So we would need more than 25 gram AF per hectare or more than that. So if we produce the pheromones in a traditional way, it would cost us a lot of money that we actually do now. And it would not be sustainable or economical to use this technology in low value crops. So Provivi has successfully found a way to produce pheromones at low cost in higher quantities using cheap raw materials. We use Nobel Prize winning patented proprietary technology to produce them. It's called biocatalysis. The Provivi was founded by 2018 Nobel Prize winner, Dr. Frances Arnold, and her graduate students, Pedro Coelho and Peter Meinhold. So we use their thoughts and innovation to produce high production with low value that we can use in low value crops to adopt this technology. Next slide, please. So Provivi has been developing both sprayable as well as dispenser technology. So the dispensers would last long, season long, while spray application should be made every three to 4 weeks. So sprayables are usually, it will be helpful for aerial applications in really broad acre crops like in Brazil and Argentina. But in our situation, I think it would be more economical to use the dispensers because it lasts long for the whole season. We just need to install these dispensers on stake and leave it for season long while they release pheromone at a constant rate and create the pheromone cloud that creates mating disruption. So on the left over here, you can see that the dispensers of corn that we have installed in Indonesia, China, and Thailand. So these are made up of porous material called low density polyethylene, and it has a liquid pheromone inside these dispensers, just like a sachet. Next slide, please. So let's look at some challenges in adoption of this technology. So we are creating a pheromone cloud. The pheromone cloud will not stay at one place. It will move as the wind direction goes along. So we need to adopt this technology in a larger areas. So in rice, we have quantified it as 4 hectares of a minimum plot size. I think in corn, it would be around 5 hectares or something like that. We're still trying to understand that in fragmented corn growing areas of Indonesia and Thailand. So if individual farmers from smaller land holding adopts this technology in larger area, it works perfectly well. Next slide, please. So while we are actually in the characterization phase for Fall Armyworm dispensers in Asia, let's look at some of the data that we have generated with the same dispensers in Mexico. And we have been doing trials in Africa, and CABI is a partner with us in Africa as well. So in Mexico, we have understood what are the benefits that we actually can create with mating disruption to create a value for the grower. On the left side of the graph that you see, it shows the leaf damage index on the graphs. On the y-axis, it is well known to us. It is Davis scale, 0 being very low damage, 9 being very high damage. So it is comparing pheromone dispenser plots, the blue line, to the current grower's practice, which is the red line. In both low as well as high pest populations, we can see that the blue line is always lower compared to the red line. That means we have reduced damage drastically through V14 stage, which is almost the end of the cropping season. So we just install dispensers once and they stay throughout the cropping season. We all know that it is very difficult to make any applications after we cross that 4 feet high or 5 feet high of the crop, which usually happens around 45 or 50 days. But what after that? If the pest population is seen after that, we cannot make applications. So dispenser technology works very well in those situations as well. Subsequently, we didn't have to spray many times, as we can see in the current grower practice. On the right side, you see that table where we have tested this dispenser technology in close to 2,000 hectares in 2019. And we have seen that it significantly reduced the leaf damage as well as reduce the number of insecticide applications. Next slide, please.
Pathi, we've got about 1 minute left of your presentation. So
last slide.
Excellent.
Yes. So due to reduction in damage and season-long control, we were able to see the low damage in the final produce as well. So one last slide. So to summarize, these are the several values for mating disruption. So broadly, we have tangible benefits that can be measured, such as insecticide application reduction, yield protection, and implementation in IPM in practice. There are intangible benefits that are a little hard to measure, like social acceptance, eco-friendly technology, low toxins in the environment and then the produce, and finally protecting our valuable insecticide molecules from developing resistance. So with that, I'll take any questions.
Excellent. I'm just going to put your slide up here. After your presentation, you had a few challenges and opportunities that I'd asked you to think about. So I'm going to put that up there as well, because I think that's quite useful to have there, Pathi. Thank you so much for the presentation. Very exciting technology, and I'm just going to go into the questions now. So just give me a second. But I do have one question before I start. What's the difference between what you're seeing in Mexico and Southeast Asia with the fall armyworm?
Yeah, so these dispenser technologies work differently at different temperatures, relative humidity, and wind velocities. So the dispenser technology have been successfully characterized in Mexico as well as in Africa. We believe it's the same technology that works very well in Southeast Asia as well, with our preliminary studies.
Okay. Here's a question. How do you look at integrating the Provivi technology with other control products or technologies?
Excellent question. Thank you very much. So we're talking about not eliminating insecticides. Okay, so we're talking about not eliminating other technologies. It's a combined effort that we need to put together, bring in all kinds of technologies to use against fall armyworm management. For example, if we use mating disruption technique for controlling a major pest like fall armyworm, it will be easier to integrate other technologies and use as a holistic manner.
Yes, good point. Another question here, how long does this pheromone work in the field?
As I said, once we put the dispenser soon after planting the corn or transplanting in rice, it will stay for season long. So we made the dispensers in such a way that we have enough active ingredient inside, and we release the pheromone at a constant rate that stays for season long until harvest.
Okay, excellent. Now, here's a question. If I understand correctly, fall armyworm is a multiple mating insect. How do you see the potential impact of mating disruption in multiple mating insect species, such as fall armyworm?
Excellent question. So that's the reason we need to have larger areas. So if you're doing it in a smaller area of mating disruption, so the fall armyworm males and females are very strong flyers. So the mated females outside the protected area with dispensers can mate and then migrate into the areas where we have dispensers and then lay eggs, and then we're not going to control them. So those situations where we need to intervene, and make a management practice with a sustainable insecticide.
Okay, excellent question, and good answer there. I've got a question here, which is always one that's asked. What are the costs to farmers per hectare to get the full benefit of this technology?
We're still in the nascent phases right now, so I cannot really answer that question. I think it will be a competitive one compared to, because we're giving a season-long control with these dispensers. So I cannot really talk about the pricing at this point of time. I have no idea.
Okay, so that's something that you're looking at. Obviously, it has to be something that's accessible for farmers to use. Here's a question. What is the risk to non-target species? Pheromone components are often shared, even if the specific blend is unique.
So pheromones are very species specific, so they would not intervene with other insect species or any other insect pests in the crop. They're very species specific. So we are controlling the major pest in the crop. So the natural enemies, so we're not spraying as much as we are doing right now, then the natural enemies will thrive and take care of the insect pest itself. So we have always seen with meeting disruption technology, the benefits of meeting disruption technology, that lesser applications of insecticides and lesser usage of insecticides will always increase the natural enemies in the field.
Okay, great. Now, you've got 20 seconds for this last question. How is rainfall patterns affecting the effectiveness of the pheromone?
That's a good question. So rainfall affects, the sprayables quite a lot, but with the dispenser technology, the osmosis effect of the dispenser technology will not allow the water seeping into the dispensers. At the same time, the cloud is not really affected by the rainfall as such. The major important thing that we are dealing with now is the temperature fluctuations and the high relative humidities that we see in Southeast Asia compared to other regions in the world.
Excellent, thank you. And that was pretty close to 20 seconds. Thank you very much, Pathi. That was an excellent presentation. Another very informative slides there with lots of information, and you have lots of questions. So if you could go online and have a look in the question and answers, there's plenty for you around where can we access this, and also technical questions. So please jump on the Q&A box and answer some of those questions. That would be most appreciated. Thank you very much.
Good, Alison. Thank you.
And now I'm hoping that Thomas Jaekel is actually with us, because I didn't see him at the start. Thomas, are you online?
Yes, I'm online. Can you hear me?
Excellent. Pathi, you can turn off your video now if you would like to have a rest from the rest of the audience. So Thomas, welcome to our session. Thomas Jaekel has directed the regional programs on the commercialization of biopesticides in Southeast Asia, and was Chief Technical Advisor for GIZ's regional program ASEAN Sustainable Agri-Food Systems, which promoted regulatory harmonization of biocontrol agents. He's now, he joined since 2017 the International Rice Research Institute, IRI, who were actually on in our last session. So it's a welcome back to them. Thomas, you have the floor.
Yeah. Okay. Thank you very much, Alison, for the nice introduction, and thank you for the invitation. Hello, everybody. I will make it hopefully short and introduce you a little bit to the regulatory situation in ASEAN. Next slide, please. Just a short overview. So I will briefly talk about the regulatory landscape regarding biopesticide, biocontrol agents in ASEAN member states. At least the situation until 2016. That was the time until I was working on that topic, but it hasn't changed much in the meantime, so to say. And then I will give you one slide preview actually of an activity of the so-called STDF project, which is called ASEAN Pesticide Residue Mitigation through Promotion of Biopesticides and Enhancement of Trade Opportunities, which is a project that has started this year and will continue until next year. And at the end, Alison asked me to give some recommendations regarding potential key actions. What can we do in the next months regarding fall armyworm in the region? Next, please. Well, I started actually working on the regulatory situation in Southeast Asia around 2008, when I joined or when I cooperated with the FAO in Bangkok. And during the project work, when I joined the ASEAN Biocontrol for Sustainable Agri-Foods project, we had a lot of exchange with FAO during that time on the regulatory situation, as FAO was doing an assessment of the pesticide situation. That means all pesticides, including biopesticides in the region, within this Asia-Pacific Plant Protection Commission platform. And at the end of this cooperation, we had a joint publication, or FAO had a publication in 2013 on this regulatory situation in Southeast Asia. And at that time, we discussed that GIZ, together with the ASEAN Working Group on Crops, would work specifically on ASEAN guidelines on the regulation, use, and trade of biocontrol agents. That was between 2012 and 2014, which included that we had an intensive dialogue with various departments of agriculture and regulatory authorities of the ASEAN member states, which culminated then or concluded in 2014 with the publication of the guidelines on biocontrol agents, which was endorsed in 2014 by the so-called senior officials meeting of the ASEAN Ministers on Agriculture and Forestry, short SOMAMAF. So these guidelines have been officially endorsed by the agricultural ministers of ASEAN member states. Next slide, please. So what are these ASEAN guidelines about? I just show you here on the left side, you see the front cover of that guidelines, this endorsed document by ASEAN, and you see also some links below there where you can download this document. I will not go into details. You see also some country collaborators who are the authors of this document, and maybe some of you are online today. The main goal and purpose of this document actually was to develop a regional framework for the regulation of biocontrol agents that facilitates more registrations nationally. Also, this guideline contains an overview over the regulatory systems of ASEAN member states, which I will not go into detail here because that is far beyond the scope of this presentation, but you can easily have a look in these guidelines and see the structure of the regulatory systems, which shouldn't have changed much since that time, but of course there will probably be some changes. And we wanted to provide a blueprint for harmonization of regulation in a sense that we could stimulate the regional trade and exchange of these plant protection products, the biological plant protection products. And I have to point out that the ASEAN guidelines on biocontrol agents was developed on the basis of following the OECD guidelines. Apart from regulation, a very important part of these guidelines is also hands-on recommendations regarding the application of biocontrol agents for sustainable agriculture of major crops. So we have vegetables, we have rice, we have fruit crops included, and we provide some examples and guidance also for standalone application, not only biocontrol in combination with IPM, but as standalone approaches for controlling of major pests. Since 2015, some of the member states have included parts of the regulation in their national legislation. For instance, Thailand has included data waivers regarding biocontrol agents. Vietnam has published the so-called Circular 21, which gives data requirements for, especially for biocontrol products. Indonesia has developed special data requirements, and so on and so forth. So just to give you an example, that parts or some countries, for instance, like Laos, have taken over these guidance document and implemented it in their national regulation.
Thomas, we'll just have to move a little bit quicker through the slides too.
Yeah, okay. Thank you. Next slide. Yeah, and this is just to alert you that there is a database available that was developed also during this work with ASEAN, and you can access this database on biocontrol products, which is also grouped into the product categories that Roma already addressed earlier. Next slide, please. If you look here on the left side, I've done a database search. What products are actually registered for control of fall armyworm in the region? And if we consult the ASEAN bioinput database, there is actually no specific product registered. But of course, some of these data are already quite old, but there are still products in this database that are registered until 2022. So it's still valid. I've also consulted the global so-called homologa pesticide database, which is also operated from Germany. And I also could not find a specific registration against fall armyworm in ASEAN member states. Although in both databases, there are products, for instance, registered against armyworm that could be applied against fall armyworm also in Asia. On the right side, I show you an overview over the major active ingredients for biopesticides and natural products, where I did a market research in 2015 together with my colleague. And you can also see in this list that there are certainly some products registered in the region that could be used against fall armyworm. Next slide, please. So a brief mention of this STDF project, which has started already. This is coordinated by Michael Braverman from Rutgers University in the US. And he's working together with the Asia Pacific Association of Agricultural Research Institutions. And this project aims, among other things, at improving technical capacity among partner countries in Asia for pesticide residue mitigation. And it also includes a component on regulatory harmonization for biopesticides in ASEAN, which is scheduled for about July next year, 2021, which I will take care of, and which I will also prepare in the first half next year, starting, for instance, also with, again, look at the current status of the regulatory system in the region. So far to that STDF project, we will certainly also announce then later in the process the exact dates of that regulatory harmonization workshop. Next slide, please. So at the end, what to do next? I put down here some ideas based on my experience now in the region. So the first thing, if it comes to mobilizing also ASEAN members, it could be possibly that we could reactivate and use the website and platform of ASEAN Crops, which is a website that was developed by ASEAN Sector Working Group on Crops and is now hosted by the DOA of Thailand. So this also hosts the bioinput database I just mentioned before. And it could be maybe used in the future to make the case for fall armyworm. Of course, we need to update the registered and commercially available biological plant protection products in the ASEAN region and in Asia as a whole. Check which products work well, what are the national or international suppliers. There are also foreign products available, for instance, in Europe. And we heard before from the speakers also from China. There are 4 fall armyworm specific products already available. For instance, in Europe, quite a good baculovirus product. So I think it will be worthwhile to check what is available. With regard to the regulatory discussion, we need to engage in a cross-country discussion, and we hope to do that again next year in 2021 to see how we can forward the registration of good quality products, be they foreign or local, and how potential registration barriers could be lowered. It's very important within the ASEAN context to remove registration barriers. There exist certain registration barriers. I cannot go into detail, but especially, for instance, semiochemicals. And as I heard the previous talk, I wish the semiochemicals good luck, but we had a stony way to get semiochemicals registered in Southeast Asia. So I feel this very important and a very important product group to look at if we look at fall armyworm. It's also important that existing government extension systems look how they can integrate, expand, or improve the supply chains for biocontrols, biopesticides. Because yes, we have technologies available, and we heard also before there are technologies under development, but distributing them and selling them is still another story. So it's very important to develop the distribution system so that they actually can reach the farmer. And this leads me to my last points. Of course, we need to consider farmers' needs and skills and the economic situation. And many people asked already about the pricing. So the absolute price tag is not so important here. We need the application rates, and we need to know the whole economic setting to judge whether a technology can be successful. So this is very important, and that needs research on the ground on the economic situation of the farmers. And I also welcome, as we heard in our previous talks already, we need area-wide solutions. So for instance, pheromones or even the classical or augmentative biological control approaches over wide areas are certainly preferred over single farmer application, because many pests are an area-wide problem and cannot be handled by single farmers. Thank you very much. This is my
excellent. Thank you so much, Thomas. That was actually extremely good. You've got excellent ideas there, and I think that's something that we need to take on board. And I just want, we're not going to have questions now because I need to move on to the next speaker, but if you could just stay there, because we're going to have a discussion now on next steps, and I'm going to come back to, we'll probably discuss some of those, many of those points that you've mentioned. One thing I just want to say, I mean, it sounds, there's some very good practical advice there, particularly around, you know, how can we maybe reactivate this database or in the website and work with the existing resources that have already had a lot of time and effort spent on them. So I think what it also says is that we have a good, you've got a good foundation there to work from. So if you could just stay online, you can turn your video off for now if you'd like, Thomas, and we're going to come back to a discussion. So it would be good to have you on board. Roma, welcome back. Thank you very much. I'm sorry we've got a bit of a time pressure here, but I know that you are all organised for this last session of the webinar. So please go ahead.
Thank you, Alison. I think that's been a very interesting session. There's some really nice ideas coming forward. So next slide, please. Yeah, just to summarise, so we're clear now, and we've heard an awful lot about natural enemies in the previous webinar. We've now heard something about microorganisms, natural substances, and semiochemicals. Hopefully sort of the terms are clearer now, and how we use these technologies is clearer. Next slide. But something I wanted to just take a little bit of a pause for is just thinking why we're using these bioprotectants for agriculture. And there's multiple reasons. And I can remember when I started working on these a long time ago, one of the things I hadn't expected was for growers that you can get good crop management. So if you're spraying a product which means you can't go back into the field for a long time, then you can sometimes, the pest or disease can get away from you because you can't monitor it because you're not allowed to re-enter the crop. When you're using some of these biopesticides, because you have no re-entry interval, you can actually have better crop management because you can constantly monitor it. And I hadn't expected sort of that to be an advantage of these technologies. So when we're thinking about biocontrol agents, thinking about biopesticides, we need to think quite widely about how useful they are and how they can contribute to good food production and good quality crop production. Next slide. So Thomas also raised this, and we've heard other people talking about what products are available. So where are they going to come from? So I sort of think of them in three groups, really. So we're going to have what's naturally occurring there. There's a possibility to implement conservation principles to encourage what existing macrobials and microbials are already present to have a stronger role in crop protection. And also we can think about IPM practices and moving IPM practices in a way that swapping out products that perhaps are damaging natural enemies for ones that are not damaging natural enemies, and just making these sort of small changes to how the food's grown and how we manage the crop. So, for example, reducing the broad spectrum pesticide uses to having much more targeted pesticides and ones that don't damage natural enemies. And those are actions that people can take now and can look at without having to wait for new products to come forward. Then the second group I think of is we're looking around the world, and again people have been talking about this today, to saying that we know that there's been issues in Brazil, we know there's been issues in Africa. So what have their solutions been? What technologies are available? And how can we look at which of those are the best technologies, and how can we bring those technologies forward to the ASEAN region? And that's for macrobials, that's for microbials, but also for natural substances. So we can use learnings from other countries to strengthen and to allow us to move fast forward in the ASEAN area. And then we can look also that we can see starting to come through are products that are specifically developed for fall armyworm. And we'll see more of those coming through. So it's finding out what those are, finding out how to work with them, and how to encourage and facilitate those coming into the region. And I think it's thinking, learning again from other countries, learning what we can do to encourage technologies to allow us to move forward as fast as possible. And Thomas has mentioned some of the resources that are available. And I just want to raise that CABI also have their bioprotection portal, and in that they're capturing it's a free access, and they're capturing what technology is available. And so there's a possibility that they can perhaps have an emphasis on fall armyworm, so that is a resource that we can go to find out what technologies are available. Next slide. I think in all of this, something that we've not said, and I think it's something to think about, is, we work with massive monocultures, and that makes it really difficult to solve these problems, because if you're an insect, you just come to a field and think, well, hey, big dinner everywhere, I can just eat everything, and it's really easy. But we also know as ecologists that monocultures are inherently unstable, and so what we're trying to do is saying, how do we make this monoculture crop more stable in terms of the pests and diseases, so we can manage our pests and just push the level down so they're not causing so much harm. So that's the approach that we're kind of taking when we're using these technologies in an integrated pest management approach. Next slide. You're going to have lots of next on this one, Alison. So next. Yeah. So the first thing that in IPM, no, sorry, go back.
Okay.
Yeah.
I've got that.
So the first thing we have in IPM is you look at the field, you look at what resistant varieties are available, what rotations, and what things that you can do. And this approach to IPM is something that isn't new, actually. Much to my surprise, when I did some research, I found out that FAO conceived this in the 1950s. So we're a little bit slow, so we need to catch up. So having worked out your best agronomic practices, how you can conserve things. Next slide, next. Then the most important part is really monitoring, really understanding your pest. When does it come in? what's it doing, how quickly is it establishing, and with this and developing warning systems, it gives farmers time to react and put in place solutions. Next. Then the next thing is putting physical and natural interventions. Can you put up fleeces? Can you put up screens? That's not likely in maize, but in some situations it works well. But again, it's thinking about what natural controls there and how can I encourage what's already existing to defend against pest. And then you come in with your biocontrol interventions, so your biopesticides. They come in next, and you use them wisely, and you use them to manage the population. And then finally, if you can't, all those technologies, all those techniques and approaches haven't worked, then you use your chemistry very wisely, and you're using it wisely so you're not damaging all the other approaches that you've tried, and so that you just knock the population back so that you can go back into your IPM programs. Next. So with all these technologies coming forward, I'm touching again on what I mentioned earlier, what Thomas has done. So what we have to think of is all these biopesticides, we have to pay attention to access and benefit sharing. So if we're bringing technologies from other countries to make sure that there's a mechanism for access and benefit sharing. Thinking about import and export rules, how can we streamline those, and thinking about the actual registration, and then what has to be registered and what doesn't. Next slide. So what can we, how can regulations support access to fall armyworm products? So what's been done in other regions to allow the flow through of these technologies into the hands of the farmers? So some of the things we've seen is there's government policy changes to have mechanisms that support and facilitate biotechnology. So there's a government decision decided we want these technologies, we want to encourage them. Put in place mechanisms for ABS so that when somebody's got a new technology, there's a way that that can be notified and to show that you have paid attention to ABS. And then for the pesticide legislation itself, the examples where this has worked well is where they've got specific pathways for biocontrol technology with data requirements that are specific to biocontrol, and that's what Thomas was touching on. Also really important is that the regulators who are working with these technologies are expert in the technology. They're not chemists, they're biologists, they're microbial ecologists, they're people who understand the technology, and they can work and act as champions for the technology and provide good expert knowledge. And then also work and experience sharing between colleagues and have peer-to-peer learning. So instead of two people doing the same thing, you can share the workload and exchange knowledge and expertise between countries. And when I've seen a regulation working well, these are the practices that are used. And then there's also the option of fast-track regulation. So in the recently developed WHO FAO guideline for microbials, botanicals and senior chemicals, sitting inside that is provisions for fast-tracking, that certain substances have certain characteristics and you can move them through the regulatory system much faster because we already have prior knowledge about their safety in terms of their human toxicity and in terms of their environmental safety. So we can use that knowledge to say, well, actually this one can be a fast track. And I think also what we need to do is to develop good efficacy protocols and guidance for specific biocontrol technologies, because doing trials for these biopesticides is completely different from doing trials of chemistry. You can't necessarily take knowledge of testing chemicals and use it to test these products. That needs to be better technology. And then the part that's very difficult for us is knowledge exchange. These are new technologies, these are new approaches, and we shouldn't forget that we have to spend a lot of time talking to farmers and working with farmers and to explain to farmers what the technologies are and how to use them wisely and support them to be able to manage their crops really, really well. Next slide. Yeah. So what are the next steps for ASEAN? Just to summarize. So, and other speakers have touched on these, and hopefully I can bring all those elements together. So the first part is this has to be an IPM biology first approach. We need to have knowledge exchange and training for agronomists, training in biocontrol. Demonstration farms work really well because farmers like talking to other farmers about what they see. So that's a really good approach. and also starting to encourage implementing conservation. And then thinking about bioprotectants, it's already active now. What are the best solutions? Where can we find those? Can we find something that's not being developed elsewhere that we can bring that in? And looking at starting to do some work about how we combine all these solutions together to build really robust and strong integrated pest management programs. And then the regulation, I've already sort of touched on, but just to summarize, it's really important to make this go fast as you have people who are expert in the technology sitting in the regulatory agencies, bringing the technologies forward, acting as champions, doing peer-to-peer learning, and also to have the shared efficacy testing. I hope that gives you a good summary of what today's session's been about and where we can move to next. Thank you.
Great, thank you very much, Roma. We've got 5 minutes. We're remembering that we're finishing at 40 minutes past today, so we've got 5 minutes for questions, and then Roger's going to give a quick summary at the very end and a few key points. I'm just going to ask a couple of our presenters today some questions, but for you, Roma, you talk about fast track, the possibility of that. What does it mean when we talk about fast track? Because I know the slow track or the normal track is quite slow, so
yeah.
How fast is the fast track?
Okay, what fast track is, it's saying there's certain technologies which have, through combined global experience, we know that they're not necessarily high risk. So based on that knowledge, so if we think about some of the microorganisms, what that document says is for some microorganisms, what's really important is there's something viable, it's a living, it's a good quality product. It doesn't contain any microbial contaminants, and it doesn't contain anything that shouldn't be in there. That it works well, that its formulation is a safe formulation. And with these characteristics, you don't need to ask for a whole pile of other data, which means you don't have to spend years doing research and studies to gather information. So it's being thoughtful about saying, what is the knowledge we really need to have to be able to make a good risk assessment to bring the product forward. So the fast track is taking that reduced data approach, but combining that with people who have really good knowledge of the technologies, so they are comfortable about making good quality decisions. And when you see that working, that sometimes these regulatory processes can go as fast as, you know, a few months rather than a few years.
Okay, thanks, Roma. Thomas, are you still with us? If you could just unmute yourself. I was just going to ask you a question.
Yes.
I have a couple of questions here. Here is a question for you, for Thomas. I'm not aware of fall armyworm specific baculovirus products in Europe. However, there are products in South Asia, Africa, USA, and Brazil. Will ASEAN countries be willing to accept registrations from these countries or regions to manage fall armyworm? What do you think?
Well, the product I know is, for instance, Andermatt Technology has that fall armyworm specific baculovirus, because I was talking to them already. But they are in Europe, of course, and they have not yet registered anything in Asia. So this is the point. So the question would be whether one would approach companies worldwide who would have interest to register these products here. Yeah. So that's the major question. Do they want to register it? Is the market prospect good enough to do that, and so on?
Excellent. Thank you.
I can also come in there. I think possibly what the questioner is asking is about the AgBiotech Forligen product, which was specifically developed for fall armyworm and is available around the world. So that they were possibly referring to that. And in terms of the data sharing, yeah, there are options for data sharing, and regulators already do that. So there is a possibility that if there's a right regulatory mechanism, that the information can be presented and have data sharing.
Excellent, thanks. Thomas, another question as well. I'm going to use the acronym here. It's the STDF, is that right, for the trade group? That sounds very interesting, particularly that you're sort of reigniting this work around harmonization of regulatory systems. How do you think we could connect the ASEAN Action Plan with that work that you're doing, particularly as this seems a very shared interest?
Yeah, well, this project, the SCDF project, works with the various representatives from the Ministry of Agriculture in the partner countries, but these are mainly the technical people. So the challenge is still how can we gather momentum next year that we also have, let's say, the political decision makers on board. Yeah, that it's not that it will not just end up somewhere in a technical discussion. So what works best and so on, and then that's it. But we need to really come to terms with the question how can we implement regulatory changes, for instance, and that needs also political decisions, mostly also from the directors of these institutions that are responsible for regulation and of the Ministries of Agriculture. And as the ASEAN guideline, for instance, has been endorsed by ASEAN ministers already, the will is there actually, or was there. Yeah. What we have to do is actually to reignite that will and try to go beyond the pure technical discussion.
Okay, excellent. And I think that's something that definitely the ASEAN Action Plan can help with and is interested in igniting. Thank you very much. I'm just going to see if Dr. Zhang is, are you still online? Could you unmute yourself? I have just one question for you. I'm not sure. I can see you there, but I'm not sure if you can hear me. Oh, there we go. I have one question here, and I wonder if you could answer it. The question is, how might the fall armyworm corn and rice strains differ in efficacy to biopesticides? Do you think there would be a difference?
To Bt strain with what? Okay.
How do you think the two strains of fall armyworm, the corn strain and the rice strain of fall armyworm, how might they differ in efficacy to biopesticides?
You mean the maize type and the rice type?
Sorry, the maize. Yes.
Yeah. Okay. Maybe the main population invented to China is a maize type. Yeah.
Yes.
In the some areas, because there were no the corn plants, so the armyworm moved to the rice field or the other crops. Right? So according to the gene sequence and the others, the main populations like corn very much. We test the different crops in front of the larvae. They choose the corn firstly. Yeah.
Yes. Okay. And would there be any difference between the efficacy of using biopesticides on the two strains, or do you think it would have the same effect?
Yeah. After the sequence, some institute scientists analyzed the sequence of the different the individual colony. They found that some population have resistant to the different pesticide. So this is why the list recommended from our Ministry of Agriculture. So they discard some the chemical pesticide. Maybe they have a resistance from
resistance.
Oh, that's
larvae.
Great. Yeah.
That's
so
very interesting.
Yeah. So this list is useful, and another the government encourage to use the biopesticide. So in the central government and local government, these 2 years they give big money to support research and control. Excellent. The control money for the 20 province around $400 million US.
Wow, that's
400.
That's impressive.
Yeah. And for the encouragement of biopesticides, the government give a subsidy to the company.
Okay.
Yeah. So the farmer only paid half money or 70% money for the products. So
Okay.
it means encourage this
Yes.
new green products. Yes.
Excellent. Thank you very much. That was actually very interesting, and that's an interesting note to discuss perhaps in our next webinar. I'm going to give Roger the very exciting part of the day, which is just a very 1 minute sort of summary. Roger, once again, I've squeezed you at the very end, so do your magic.
Thanks, Alison. We've heard a lot of good stuff, and we've heard a lot about effective biopesticides, and in a way that's not the problem. We've heard that there are other issues that we need to address to get them used. There's the regulatory issues, the practical issues, and the economic issues. In terms of what we should be doing straight away, there are lots of things, and they will mature with different timescales, but in the very short term, in a country, you should be looking at what products are already there, registered for other similar pests that maybe you could get a label change or extended registration or emergency registration for fall armyworm. You can then look at products that are registered for fall armyworm in other countries, see how you get them registered in your country. And of course, in the longer term, we'll hope we can get these regulatory procedures harmonized and smoothed so that we can get more bioprotectant products registered for fall armyworm and other products. So things to get going on, but they will mature, they will give results with different timescales. And of course, farmers are waiting for answers now. So think especially about the short-term ones. Thank you.
Excellent. Thank you, Roger. That's extremely good summary there. I think it's really touched upon the key points that came out for me as well. I'm really sorry, everyone, we finished 2 minutes late, but I think with everything jam-packed in there, all the information that was shared, it's been worth it. And thank you for staying on right through to the end. We've still got most of you on that have actually started from the very start, so that's always a good sign. Remember, we have our webinar 3 on the 8th of October, so please join us there. It's actually 4 to 5:30, so the time's not quite right there, but we'd love to have you on board. And I'd like to say thank you so much to all the speakers. Really excellent presentations, lots of detail, and you shared lots of information and resources with us as well. Thank you to all those who are online, and to Grow Asia, we'd just like to say thank you to everyone, and to Pranav, the person behind the scenes helping to make sure this webinar runs smoothly. Thank you very much. Good night or good morning, and we'll see you next time. Safe journeys or safe travels, or have a great day.